All right, let's walk you through at least one application of the first derivative test. If we have this function g of x, which is a polynomial of degree 3, and we take the derivative, we get 3x squared minus 12x. If we set the derivative equal to 0 and factor, we can factor a common factor of 3x out, leaves us with 3x times x minus 4 is equal to 0. The only way that this product is equal to 0 is either if x is equal to 0 or x is equal to 4. So what this basically does for us is it defines intervals. So starting at negative infinity, you write an interval from negative infinity to 0. Then you write the next interval from 0 to 4, and then you write the last interval from 4 to infinity. And you pick a test point on these intervals. So on the first one, I picked -1. On the second one, I picked 2. And on the third interval, I picked 5. I plugged all of these into the derivative. So -1 gave me a negative times a negative, which was greater than 0. So on this particular interval, it should be increasing. Negative infinity to 0, I have an increasing graph. Again, at 0, I have a flat horizontal tangent line, so actually 0 is going to be a max. And then from 0 to 4, if I pick a test point such as 2, if I plug in 2 into the derivative, g prime of 2 gives me a negative number, therefore it's decreasing. And then if I plug in a test point here between 4 and infinity, g prime of 5, for example, gives me positive 15, which is greater than 0. So I have, again, a negative slope leading to a 0 slope leading to a positive slope, so this is a minimum. If you want to know exactly where those are, you have to plug them in the original function. If you took 0 and plugged it in the original function, you'd get 15, so 0, 15 is a max. If you took 4 and did some of the side math, same as I did over here, I hope you got the same answer. But if you took 4 and plugged it in this equation, you get -17. So 4 comma -17 is a min. So again, it's all about setting the derivative equal to 0, finding intervals starting at negative infinity and going all the way to positive infinity, and picking a test point in those intervals. If you plug that point into the derivative, if it's positive, it's increasing on that interval. If it's negative, it's decreasing on that interval. Thanks.